All right, our first link here, we are trying to determine if these ratios are equivalent. Okay, so one thing we can do is put them into a proportion and then see if they're equal. So we have 3 full-time employees for every 1 part-time. So that makes a ratio there, just that information. 12 full-time employees for every 4 part-time. So the first time I put full-time on the top, so I have to keep full-time on the top on the right side. So I have to put 12 on the top. I put part-time on the bottom, so I have to put part-time on the bottom on the right side as well. So I have 3 over 1 and 12 over 4. Now 12 over 4 actually reduces to 3 over 1. So both sides reduce to the same ratio. So yes. Good. Same thing on this one. Our labels are forks and knives. So on the top, in my proportion, I'm going to put forks. On the bottom, I'll put knives. So we have 10 forks for 12 knives. We have 13 forks for 9 knives. Now if we can reduce these, we will, and if they equal to be the same, then the ratios are equivalent. 10 over 12, both of those are divisible by 2. That becomes 5 over 6. However, 13 over 9, 13 is a prime number, so I can't reduce it. So that stays 13 over 9. Okay, those two are not equal, so they are not a proportional relationship, so I would say no. Okay. Okay, here we have labels of elementary students, and we have labels of middle school students. So when I write my proportion, I'm going to put ES on top for elementary students. I'm going to put MS on the bottom for middle school students. I have 8 elementary students for every 18 middle school students. I have 4 elementary students. That has to go on top because that's where elementary students are. For every 9 middle school students. Do any reducing that I can. 2 goes into 8 and 18. 8 divided by 2 is 4. 18 divided by 2 is 9. The other side I cannot reduce because there's no greatest common factor that goes into both of those. But I get 4 ninths and 4 ninths. They are equal. It's the same. So are they equivalent? Yes, they are. Okay, the second one. Same thing, but it just looks a little bit differently. So we have do the ratios 3 over 1 or 3 to 1 and 18 over 6 form a proportion. So again, let's write them in proportion form. If they reduce to the same ratio, they're equivalent. 6 goes into 18, 6 goes into 6. 6 goes into 18 3 times, 6 goes into itself once. And on the other side, it can't be reduced, it already is. 3 over 1 equals 3 over 1. So do they form a proportion? Yes, because they're equal. All right, we have 9 18ths and 1/2. Again, 9 goes into 9 and 9 goes into 18. That reduces to 1/2. 1/2 equals 1/2. So yes, they form a proportion because they're the same ratio. 3/5 and 2/4. 3/5 we cannot reduce because 3 is a prime number and so is 5. It's already reduced. 2/4, 2 goes into 2 and 2 goes into 4. That reduces to 1/2. They are not equal, so it does not form a proportion. All right, kind of the same thing we did the first time. Do these ratios form a proportion? Again, our labels, large sheets and medium sheets. So when I set up my proportion, I need to put my labels in place so that I put the numbers in the right spot. So I have LS for large sheets, MS for medium sheets. So I have 18 large sheets for every 2 medium sheets. 18 on top, 2 on the bottom. 9 large sheets for every 1 medium sheet. 9 on the top with the large sheets, 1 on the bottom with the medium sheets. This I cannot reduce because it's already to 1. This would be called a unit rate. This side I can reduce because 2 goes into both of those, 18 and 2. 2 goes into 18 9 times, 2 goes into itself once. They become the equal, same ratio. So yes, it forms a proportion. Okay, again, we have pies and pies. We have cakes and cakes. Set up our proportion. We're gonna do P for pies and C for cakes. All right, 8 pies for every 10 cakes. So 8 goes on top, 10 goes on the bottom. 12 pies for every 15 cakes. 12 on top, 15 on the bottom, and reduce. We can actually reduce both of these. Let's see, 2 goes into 8, 2 goes into 8 4 times, 2 goes into 10 5 times. Over here, the greatest common factor here is 3. 3 goes into 12 4 times, 3 goes into 15 5 times. Turns out to be the same ratio, so yes, forms a proportion. Okay, select the graph that shows a proportional relationship. Okay, remember from the notes, if it's a proportional relationship, it's a straight line that goes through the origin, which is 0, 0. This one does not go through the origin, so it's not a proportional relationship. This one does, and it's a straight line, so that forms a proportional relationship. This one goes through the origin, straight line. This one goes through the origin, straight line. They're both proportional relationships. So remember, any points on these lines are included in the proportional relationship. So for example, this point 9, 5 is right on the line here. So that would be included in the proportional relationship. Okay, so both of those. Through the origin, straight line. Through the origin, straight line. Good. Okay, now we're getting to the equations. Remember, the equation for a proportional relationship is y equals mx. It has to be in that form, where m is a ratio, or the unit rate. Okay, so this first one has y equals 4x squared. It's close, but we do not want the squared. That changes the whole look of the graph. So it's not the first one. The second one is y equals 2x, matches this form. That is a proportional relationship. This will give you that straight line through the origin that we need. This will actually give you a U-shaped line. That is not what we want. We need to have a straight line. All right. This one matches the form, so does this one, y equals mx. Okay, this is by far the most challenging link on this standard, on this section. But what we need to do is we need to take these ratios and divide them. If they reduce to the same unit rate, then it makes a proportion. Okay, it says the following table shows the time it takes to ride the elevator to 3 different floors of a skyscraper. We have the floor number, we have the time needed in minutes. Based on this table, is the floor number proportional to the time it takes to get there? Okay? So what we need to do is figure out if these ratios are proportional. And if they are, they will all reduce to the same unit rate. They all simplify to the same unit rate. So let's start with the first one. We have 4 over 0.25. Okay, remember a fraction really means the same thing as division. So this would be the same as 4 divided by 0.25. So we can change that to a fraction so we can divide a little nicer. 0.25 is 1/4. Now we don't divide fractions, so we have to KFC. Becomes 4 times 4 over 1, which the first one is over 1 also. 4 times 4 is 16, 1 times 1 is 1. Okay, so it reduces or simplifies to 16 over 1. The second one we can see is already 16 over 1, so that's nice. Now let's see if the third one reduces to the same thing. 16 over 4, 64 over 4. 64 divided by 4 is actually 16. So that would be 16 over 1. So all three of these reduce to the same ratio, so they would be proportional. Okay, Cam is a corrupt politician. Nobody votes for him except those he pays to do so. It costs Cam exactly $100 to buy each vote. Okay, if you're ever a politician, I don't recommend this. It's not the way to go. All right, are Cam's costs proportional to the number of votes he receives? Okay, so it says he gets exactly $100 for each vote. So $100 per vote, $100 for one, okay? It would be proportional because we can write it out as a unit rate, $100 to 1. For each ticket, he gets $100. So if we were to graph that, one ticket would be $100. So there'd be a point there. 2 tickets would be $200. A point there. 0 tickets would be $0. So that would go through the origin right there. And then we could connect those points and it would make a straight line. So because the information, when graphed, makes a straight line through the origin, it's going to be proportional. And also, since we can think of it as a unit rate, it's going to be proportional. So we would say yes. Apples are on sale for $3.12 per kilogram. Is the total cost of the apples proportional to the total mass? Okay, apples are on sale for $3.12 per kilogram. Again, that gives us a unit rate. It's for 1, so that will be proportional. Whenever we can write the information as a unit rate, we know it's going to be proportional. So we would say yes, it is. Length of the shorter side proportional to the perimeter. Okay, so here's the shorter side. So we're going to make a table, and we'll use S for shorter side. We'll use P for perimeter. So length of the shorter side, since they just give us a letter, that means we can pick any number we want. So let's say y is 1. So length of the shorter side is 1. The perimeter, this would be 2 times 1, which is 2. So this would be 2, that'd be 1. So it'd be 2, 4, 5, 6. So the perimeter is 6. Okay, now let's change our y to be 2. If y is 2, this would be 2, this would be 2, this would be 2 times 2, which is 4, and that would be 4. So our perimeter would be 4, 6, 10, 12, 2 and 12. Okay, now if these reduce to the same thing, we can say they're going to be proportional. So 2 over 12, greatest common factor is 2. 2 divided by 2 is 1. 12 divided by 2 is 6. So yeah, they reduce to the same ratio. So we can say they are proportional. All right, does the following table show a proportional relationship between G and H? So again, if these all reduce to the same thing, they're going to be proportional. So 3 over 9, greatest common factor is 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Gives us a third. 6 over 36, greatest common factor is 6. 6 divided by 6 is 1. 36 divided by 6 is 6, so they're different. So we already know they don't reduce to the same unit rate or the same ratio. They're not proportional.